So we are going to talk about the immune system now. And the function of the immune system is for protection. So this is protection from different types of pathogens. So for example, bacteria that are pathogenic. So pathogenic meaning causes disease. So certain bacteria, like those that would cause something like strep throat, or ear infection. There are lots of bacteria, however, that are in our body that are very important for our body. So not all bacteria are pathogens, meaning that they cause disease, but our immune system is going to sort that out and figure out what is a pathogenic bacteria and try to protect us from those. Also things like viruses. So viruses that can give us something like the flu, the influenza virus, also rhinitis, which is something that gives us the cold. Other things like West Nile, chicken pox, things like that, so different types of viruses. And then other types of organisms, so things like parasites. So protecting us through parasites like those that give us trichinosis. So trichinosis, which can come from eating raw meat. Also something that would give like malaria. Malaria is a parasite that lives in the blood. So parasites and other different types of things like fungi and also some protozoa. So those are different types of pathogens that the immune system would be protecting us from. But the immune system also protects us from things like cancerous cells. So from cancer. And cancer is due to unrestricted or unrestrained cell division. So in excess of mitosis would be a cancerous type of cell, and then it would become cancer, and then we would have cancerous tumors perhaps that would be in the body. And so our immune system is going to try to protect us from pathogens, but also from cancer. So first what we're going to do is we're going to take an overview look at all the different types of cells that we find in the immune system. And so we're going to take a look at this image here that we have seen in the blood system when we talked about the blood and the cardiovascular system. And we're going to revisit this because we're going to take a look at some of these specific cells, and then we're going to get into how each of these cells work with the different types of functions. So first of all, cells are important to the immune system. Remember, our white blood cells are called leukocytes. So we're going to be looking at the leukocytes on this table here. Our leukocytes are found all over the body. And so our immune system is all over the body, including in the blood. We do see a lot of those in the blood. They're formed in the blood, remember, and then are in the red bone marrow, and then they go throughout the bloodstream. But they're also all over the body, meaning that many of these cells actually leave the bloodstream and go throughout the rest of our tissues. So some of the blood cells that we're going to be taking a look at, or some of the leukocytes specifically that we're going to take a look at, are over here. So we have, let's say, our neutrophil. That's our most common, the one that we have in the highest number, are neutrophils. These are our major phagocytes. So our neutrophils, and they are phagocytes. If we recall what phagocytes are, or phagocytosis. Remember phagocytosis, which is cellular eating. So our neutrophils are going to be the type of leukocyte or white blood cell that's going to be meandering throughout the body and in the bloodstream that is going to be a major player as far as eating up pathogens. So it will indicate, or it will find a bacterium. It will note that it is not self, and then it will go through the process of taking that bacteria into itself and breaking it down into pieces. Another white blood cell we'll take a look at are the eosinophils. So our eosinophil. These are the ones that are going to be fighting parasites specifically. So they mark parasites and they try to break down parasites, so things like worms in the body. Next, we'll take a look at the basophils. So our basophils as well as our mast cells. So our mast cell is up here, and then our basophil down here. These two cells, you can actually see that they have a lot of granulation, which are all these little dots there that you can see, kind of gritty looking. And those granulations, same thing with eosinophils, but our mast cells and our basophils are both mediators for inflammation. Oops, I forgot mast cell here. Mediators for inflammation, and we're going to talk more about inflammation a little bit later. But these cells are the ones that are going to indicate and are going to assist in inflammation. These two, by the way, also the basophils and the mast cells, are what we see in allergic responses. And when we have an allergic response, this is because these cells, the basophils and the mast cells, are becoming overly sensitive to things that we would consider not harmful. So they're just overly sensitive. And then that gives us an allergic response. So we have inflammation due to something that is not particularly harmful to the body. So things like pollen or pet dander. And so then we activate this inflammation, but it's under non-harmful circumstances, and that's what we call an allergic response. So then, let's kind of move this up a little bit here. The next type of cell that we're going to take a look at are macrophages. That's this big guy down here. So our macrophages, our macrophages are our second phagocytic cell. So our macrophages along with our neutrophils. So our neutrophils and our macrophages are two of our major phagocytic cells. And so our macrophages actually are those that are going to be moving throughout the body the most. So they kind of move around the body, the macrophages, looking for things that are not self and then gobbling those up and breaking them down. So all of these cells that we have just talked about so far, the neutrophils, the eosinophils, the basophils, the mast cells, and the macrophages, are all actually going to be part of the first two kind of types of immune system that we have that are our, let's see, I'll write down here. So our non-specific immune response. And we'll talk about this more as we talk about the nonspecific immune response. But I just want to make that clear because now what we're going to mention are more related to our specific immune response. With one exception, but we'll talk about that. So and we'll talk about what nonspecific and specific are, but right now I just want to go over the cells and then we'll get into the details. So the next type of immune system cell that we're going to mention are lymphocytes. And so we have two different types of lymphocytes. We have our B cells, or B lymphocytes, and we have our T cells, or T lymphocytes. And both of these, we're going to talk about them in more detail when we get to the specific immune response. But as the name implies, they are specific to a pathogen. So they actually are able to recognize a specific type of pathogen and then attack that specific type of pathogen. If we look up here at our chart, here you can see our B lymphocyte and our T lymphocyte, and this includes the plasma cell that comes from the B lymphocyte. So these are our lymphocytes here. Then the last type of cell that I do want to talk about is another type of lymphocyte cell called the natural killer cell. Now this guy is up here and is a type of lymphocyte. However, it is actually not part of the specific immune response. This guy would go back up here to the non-specific immune response. And again, we'll talk about that in more detail, but our natural killer cells are a type of lymphocyte that kills viruses, or rather kills the cells that are infected with viruses. So let me back up there. So virus-infected cells. So not part of the specific immune response. They can indicate or they can determine if a cell is infected with a virus, and then it can kill that cell. Also, cancerous cells. So our natural killer cell is unlike the other nonspecific immune response cells in that it is going to determine if one of our self cells is infected with something or is cancerous, and then it will kill our own cell in an attempt to get rid of the viruses or an attempt to stop the cancer from spreading. So these are all the different types of cells that you should be familiar with, and we're going to talk about these and how they relate to the different types of the immune system as we move forward here. So as I mentioned, we kind of split up the immune system into pieces. And so when we split it up into pieces, we generally split it up into our innate or non-specific immune response and our adaptive or specific immune response. And so when we look at these two kind of divisions of the immune system, we're first going to talk about our innate or non-specific immune response, and then we'll talk about the adaptive or specific immune response. We split up now the innate or non-specific immune response then into two different lines of defense. So we have the first line of defense, and our first line of defense is really barriers. So our first line of defense are our barriers, our external barriers, and other physical barriers, meaning things like our mucous membranes. So our first line of defense are going to be things like the skin. So skin is a barrier. It's an actual physical barrier to preventing something from getting in the body. We'll talk about that in a little bit more detail in just a minute. Because the first line of defense includes these barriers, these external barrier like the skin and our nails and our hair and things like that, as well as other physical barriers like the mucous membranes. But then it also includes the secretions of the skin and these mucous membranes. So just in addition to that, we have our secretions of the skin and the mucous membranes. And we'll talk about all of these in more detail. So that's our first line of defense, part of our innate non-specific immune response. Then we have our second line of defense, and that's also part of our innate non-specific immune response. So our second line of defense. So our second line of defense includes things like our phagocytic cells, our natural killer cells. It also includes things like fever and the inflammatory response. So this is when something has now gotten into the body, right? Our first line of defense has been breached, it's gotten in, and now we're at our second line of defense. And this is, again, non-specific. So these are just things that are going to try to get rid of something that's in the body. Then our third line of defense is down here as part of our adaptive or specific immune response. And so our third line of defense, this is when we're going to be taking a look at those specific lymphocytes, the B and T cells, and then also we'll be taking a look at antibodies, so utilizing antibodies in the body, and then also macrophages are a part of our third line of defense here, our adaptive or specific immune response. So these are 3 different lines of defense, and by saying lines of defense, we really do mean that once something has breached the first line, then we go to the second line of defense. Then if it's the second line of defense isn't working, we're moving into the third line of defense. And so let's take a closer look at our first line of defense. So again, as we said, the first line of defense, I'll just write first here. Our first line of defense are going to be our barriers. So our external barriers, physical barriers, our mucous membranes. And so what we're talking about again is the skin. That's our external barrier and the things that go along with the skin. So our integumentary system, so things like our nails, our hair, things like that. So these are physical barriers, right? Just trying to keep the bad guys out. Our physical barriers to any foreign materials. And then we also have our mucous membranes. So when we talk about mucous membranes, what we're talking about are things like our digestive system. We have our digestive system, which is lined with all sorts of mucus and different things that we're going to talk about that are secreted. Also things like our respiratory system. Our respiratory system and our trachea and our bronchi that we'll talk about. We have cilia and we have mucus trying to get anything out. So that's also a part of our first line of defense. Also in our reproductive systems. Specifically in the female reproductive system, in the vagina, we have a change in pH, a decrease in pH. That's one way to try to have a first line of defense to not get something into the body that could be pathogenic. So we have our skin, which is our largest physical barrier on the outside there, and then we have our various mucous membranes. And then remember, part of the first line of defense are also the secretions of these mucous membranes. So for example, our skin itself, right, has secretions, so the pH of the skin is low, it's acidic, and so that's meant to inhibit bacterial growth. So that inhibits bacterial growth. Also sebum, right, so the oil that is on our skin is toxic to bacteria. And then in our mucous membranes, for example, in the digestive system, we'll just shorten it here to GI tract. For example, in the stomach, we secrete something like hydrochloric acid, which has a low pH, which is meant, at least in one way, to inhibit bacterial growth. Or inhibit bacteria in general, because it will kill the bacteria. We also have things like protein digesting enzymes. That will digest the proteins that the bacteria, for example, have on the outside of their and their plasma membrane and their cell wall. Also, things like saliva. We have enzymes in our saliva that are going to break down the bacteria, try to kill the bacteria, and also in our lacrimal fluid, our tears. In both of these, we have something called lysozyme. And that's the enzyme that destroys bacteria. Also, we have mucus, right? So part of these secretions is the mucus itself. And the mucus is sticky, and it's going to prevent the bacteria from moving further into the body. So it sticks there, and then we can cough it up if it's in our respiratory system, for example, or in the throat. We can cough it up and try to get that out. Also, in the nasal cavity, we have mucus so that we can sneeze things out. So it traps these organisms and tries to get them out of the body. So this is our first line of defense. Another and last piece of our first line of defense, another secretion that we have is called interferon. And interferon are various proteins that are secreted by cells that are infected by a virus. So proteins that are secreted by virus-infected cells. And so what this does is that when a cell, one of our self cells, is infected by a virus, it's going to secrete these interferon proteins. These interferon proteins then are going to stimulate the cells around it to produce antiviral proteins to protect them from the virus so that they don't get the virus and they don't get infected. So this is going to interfere with the virus being able to move on to the cell next to it and then infect that cell. So these proteins are secreted by the virus-infected cells. Then they will bind to nearby cells, which then produce antiviral proteins. And so then they hopefully will not get infected. So this is our first line of defense. So again, our physical barriers, our skin, our mucous membranes, and then those various secretions that we talked about, including the interferon. All right, so now we're going to take a look at our second line of defense. So again, part of our non-specific innate immune system, so just it's already built in, and it's just going to try to get rid of any bad guys, anything that doesn't seem like it's self. So here's our second line of defense. So remember, our second line of defense included different cells and chemicals. And we'll talk about those specifically. So the first one that we're going to talk about, the different types of cells, are phagocytes. So now that we've gotten past the first line of defense, we're in the second line of defense, meaning that our barriers didn't work. And so we have a bacteria in the body or a virus is in the body. And so here we are, now we have a bacteria in the body and we want to try to get rid of it, try to protect the body. So we have our phagocytes, or phagocytic cells. Remember, those are going to engulf a bacterium and break it down using different enzymes. So recall that these are neutrophils and our macrophages. So our neutrophils and our macrophages are going to engulf the foreign material into a vacuole. And then that vacuole is going to be combined with a lysosome, which is our vesicle. Filled with enzymes. And so this vesicle filled with enzymes is going to be used to break down whatever foreign material it is. So we could be talking about a bacteria, we could be talking about some sort of debris that's gotten into the body. So if we look at our cell, so we have our phagocytic cell here, and let's say it does come upon a bacteria here. It's going to recognize that this bacteria is not self, so it's going to get close to it. So this moves closer. And then it's going to recognize that it is not self. When it recognizes that it's not self, then this is our plasma membrane out here. So we have our nucleus in here and various other organelles and things, right? This is supposed to be our endoplasmic reticulum and different mitochondria and things like that within the cell. So here is our cell. It recognizes that this is not self, that this is a bacteria. I can probably write that. Bacteria, and then this is our phagocytic cell, or phagocyte. So once it recognizes that it is not self, then it's going to take this plasma membrane and it's going to bring pieces of it out like this and then start to engulf the cell. So if I get my little eraser here, get rid of this part. And so the plasma membrane has kind of come out from the cell, and these little arms are going to go around and it's going to grab the bacterium. Once it does this, it's going to continue moving around until it creates this little tiny vacuole. So now the bacteria is in this little plasma membrane vacuole, and it's brought into the cell. And then we have our little lysosome here, which is filled with all sorts of little enzymes, lysozyme and other enzymes that can break down things that are inside of a bacteria or other types of debris. So this is going to move over and it's going to bind to the vacuole that the bacterium is in. Once it does this, then they actually merge because all of this stuff is made out of plasma membrane. So they end up merging together Once they do that, all these enzymes are going to go in here, and they're going to break down that bacteria now. And then they're going to break it down into the pieces, and then this macrophage or this neutrophil is going to use the pieces, recycle them, get rid of them, whatever it does with each of the pieces, depending on what the body needs, depending on what the piece is. So we have our phagocytes as part of our second line of defense. It's going to engulf this foreign material, bring it in, break it down. Then we also have our natural killer cells as part of our second line of defense. So let's take a look at our natural killer cells. NK. So our natural killer cells actually are going to do something similar but different than our phagocytes. So our natural killer cell, let's say here's our natural killer cell, same thing, it has a nucleus and all these different organelles that we've talked about. So our natural killer cell is going to come upon a cell that has been infected with a virus or is cancerous. So this would be like one of our own cells. So I'm just going to kind of make it a cuboidal cell here with the nucleus. And then it's going to notice that this is an abnormal cell. So we have markers on our cells. This cell actually puts a marker out there saying, I'm infected by a virus. So then the natural killer cell hooks on and notices that it's saying, hey, I'm infected by a virus. So it recognizes this and it sticks to it. Then what happens is the natural killer cell, that's this guy here, the NK cell, and this right here is the infected cell. So the natural killer cell is then going to secrete something called perforins, or different molecules called perforins. So these perforins are actually proteins that embed in the plasma membrane of the infected cell. So our natural killer cell here is going to release these perforins. I'll do it up here. So it's going to go pew, pew, shoot these little perforins out. And what it does is it embeds these little proteins inside of the plasma membrane of our infected cell. What this does then is it actually creates a hole in the cell. So in here, it creates a hole, or a pore, as it's called. So these perforins go in here. They actually shoot several of them. If I kind of did a close-up view here, what it would do is if this is, I guess that's a pretty poor way to draw that. If this is the plasma membrane, right, so all of our little guys here, these are the heads of the plasma membrane, let's say. So if I'm shooting down these perforins, what they do is they end up kind of shooting this here, and then here, and what they do is they shoot in kind of a circle here, and if we were to look down at the plasma membrane, we would see that these little perforins actually form a pore. So the way that they shoot in is lined up in kind of a circle shape here, and then that creates a pore. So now this is open, and now what can happen is things can flow inside of the cell. So in here, they're going to flow inside of the cell, including some enzymes called granzymes. So granzymes are actually going to go into the cell, and then it's going to start to break down the cell, all of the stuff that's inside of the cell. Also, because there are holes now in the plasma membrane, now we're going to have some fluid. We'll just put water, but it's a fluid and a mix of the different fluids of the interstitial fluid. And then that's going to, or extracellular fluid is going to go into the cell, it's going to swell, and it's going to burst. And so then what happens is this cell is going to burst, and since it bursts, that stops the infection. So if a virus is in there and it was replicating, making copies of itself, then hopefully it didn't get very far in making copies of itself, and now that's burst. And then remember, we also have the cells releasing interferon, and when they do, the cell that's next to it, right, so the cell that's next to it hopefully has already gotten those interferon molecules and is not affected by all of these little viruses that are now being burst out of this cell if they're already made viruses. So this is how our natural killer cells work. They can destroy our virus-infected cells. So I should write that up here. So our virus-infected cells. and cancerous cells. So again, this is part of our second line of defense, right? Because we're recognizing this, but it's not specific to a specific pathogen. Any cell that's infected by a virus is going to have this treatment by the natural killer cell. Any cell that's cancerous is going to have this treatment by the natural killer cell. It's not specific to a specific pathogen. So moving on with our second line of defense, our second line of defense also includes fever. So fever is an increase in body temperature. And this is abnormally high body temperature. So it's an increase in the body temperature in response to an infectious, that's not spelled correctly, infectious agent. So if we get a pathogen in the body, in response to that pathogen, we're going to have a fever. We're going to increase the body temperature. And the way this works is the cells that are near this injury site, for example, or where a debris has gotten in, where bacteria is in, where a virus is in, these are going to release things called pyrogens. So pyrogens are substances that cause the hypothalamus temperature set point to be increased. So substances that increase the body temperature set point in the hypothalamus. So the pyrogens are produced by the pathogens as well as our own cells. So produced by the pathogens and our own cells. So when our own cells are infected, then they say, hey, and shoot out these pyrogens, put these pyrogens out there, they go up to the hypothalamus increases the body temperature. The reason this is done is because this increase in body temperature, the increase in body temperature is not good for pathogens. So it's not good for pathogens to reproduce. So we are the types of pathogens that are going to get into our body, that are going to infect our cells and affect our body, are the type of pathogens that like to be around our human body temperature, so our 98.6 degrees Fahrenheit. So they like to be around that temperature. If our body then increases its temperature, then it's not in a real comfy spot for these pathogens. And so these pathogens are not going to go through the process of reproducing because they're in an uncomfortable spot. So if we increase our temperature, then we decrease the ability for the pathogens to reproduce. They're not in a happy spot, so they're not going to reproduce, which gives our body time to come in and get rid of the bacteria or the pathogen that's already in there. Also, what this can do is it actually inhibits the release of iron and zinc from the liver and the spleen. So it decreases the release of iron and zinc from the liver and the spleen. And both of these, iron and zinc, are needed for bacterial replication. Meaning that our body, when we have an increase in body temperature, we decrease the release of iron and zinc in the body, and when that happens, then the bacteria don't have the iron and the zinc that they need to reproduce. So not only do we make the temperature not real happy for them, we also don't try to give them, or we try to prevent them from getting the nutrients that they need in order to reproduce. And lastly, this actually increases the speed of tissue repair. So an increase in temperature actually increases the speed of our own tissue repair. So kind of we have these three things happening with fever here, and this is related, and this is due to these pyrogens being released. And then, of course, the set point being changed. So the last type of second defense that we're going to talk about is inflammation. So again, we're on our second line of defense. Our last part of the second line of defense is our inflammatory response. So this is triggered when our body tissues are injured. So any type of tissue injury is going to cause inflammation. And there are 5 signs of inflammation. So the first sign, these are kind of signs of inflammation to know whether or not this is what's happening in the body. The first one is heat. This is related to an increase in blood flow. The second one is edema or swelling. And this is also related to an increase in the blood flow. Most of these are related to an increase in blood flow. So heat, edema, pain or itching. So of course this is because we have our receptors, and if we have injury to a site, these receptors are picking up on that. They're releasing them and becoming sensitized. And then impaired function. Oops, I forgot the first one, or I forgot another one, sorry. And then redness. Redness. And this is, again, increase of blood flow. So if we have more blood going to the area, it's going to be more red. That also is going to bring more heat. Our blood is very warm. It's coming from our heart, from inside the body, so it's going to increase the blood, or increase the heat in the area. We have some swelling. If we have increased blood flow, we actually have increased water moving out of the blood and into the tissue, so we have increased edema or swelling. We have pain or itching because those receptors are picking up on the tissue damage. But then also because of an increase in blood flow and bringing things to the area, we have some changes in that area. Remember, that's a release of prostaglandins. We'll talk about that in a moment, but then we also have impaired function, and this is also due to the increase in blood flow. We have a lot more fluid there. It's also due to the swelling. So these are our 5 signs of inflammation. And inflammation, all of this is going to result in a chain of events that's going to lead to protection and lead to healing. So our injured cells are going to release chemicals like prostaglandins. And these prostaglandins, in turn, are then going to cause this inflammation. So they're going to release prostaglandins. When they release prostaglandins, what's going to happen are leukocytes. Our leukocytes are going to be attracted out of the bloodstream to the site of infection. Or injury. So our leukocytes, remember those are our white blood cells, are going to be pulled out of the bloodstream and go to the site of infection. This is called chemotaxis. So chemo meaning chemicals because we've released prostaglandins, so it's in response to these chemicals, and taxis meaning movement. So movement in response to chemicals. So our leukocytes, our white blood cells, are going to be moving in response to these chemicals. So they're going to leave the bloodstream and move to the site of injury or infection. Then most of these, so this is actually where we see our neutrophils. Our neutrophils are first on the site. They're kind of our first responders. And remember what our neutrophils did. Right, our neutrophils are phagocytic. And so our neutrophils are going to get there. They're going to go in and they're going to start gobbling up and digesting any foreign material. So they're going to squeeze out of the bloodstream. They're going to go to the site of injury, to infection. We have our neutrophils that are going to go there, and they're going to start gobbling up pathogens. Then we actually have other cells that are going to be coming as well. So like our macrophages are going to come, and they're going to start gobbling things up as well. And remember, those are also phagocytic. So mostly what's happening there is we're bringing a lot of these white blood cells that are going to start eating up and digesting any foreign cells and any debris. That includes the actual cells of our cells that have been broken apart into pieces. So then the whole point of inflammation, right? So when our body tissues are injured, we go through this process of inflammation. And then this is going to limit the spread of the pathogens. Also, it's going to kill the pathogens. So it's going to limit the spread in that we can look at these 5 different signs up here. So it'll limit the spread because we'll have edema, which is a lot more stuff for these pathogens to try to get through. The increased heat increases the temperature, similar to fever, to where these pathogens are going to have a hard time. They're not going to be reproducing. Impaired function because of all of this stuff coming to the area. So we're limiting the spread of the pathogens. We're also killing the pathogens with our neutrophils and our macrophages that are killing them, as well as we are removing debris. And when we say that, we do mean, like, you know, if you got stuck by a stick or something like that, there would be little pieces of that stick in there, and our macrophages and our neutrophils are going to come and gobble that up. But also that means our broken cells, our broken blood vessel cells, our broken skin cells, things like that. And then it initiates tissue repair. So it actually is going to also be bringing things to the site in order to initiate the repair of that tissue. So that's the last part of our second line of defense. So in this lecture, you should be familiar with all of the different types of cells, the immune system cells. We talked about the different cells. First of all, with the function of the immune system, and then our different cells. Then we talked about neutrophils, eosinophils, basophils, mast cells, macrophages, lymphocytes, B cells, T cells, and the natural killer cells. Then we talked about our different lines of defense, our innate specific immune response and our adaptive immune response. Then we talked through the first line of defense. That includes our physical barriers, our mucous membranes, as well as those things that are secreted by those things, as well as our natural killer cells there. We can talk about the natural killer cells and how they're going to be attacking cells that are infected with viruses or cancerous. Then we have our fever, our increase in temperature so that we can try to fight off things, and then inflammation that we spoke about.